All right, guys. Well, I hope that you were able to get some of these done on your own. I would probably suggest that you just kind of take this video and pause it so you can check your answers against these. Remember, they are exact lengths, so we did not try to approximate in between the whole numbers that they were, or to the nearest tenth or anything, right? All right, and then I asked you to think about your thinking, how you came up with a strategy maybe for what you would do when you took the grid away, okay? So if we take the grid away now, we can't just count that length, right? I need the length of this leg. This is a vertical length, right? And all I'm given are the coordinates. So this y coordinate of 2 and this y coordinate of 6, right? So a vertical length like that would correspond to y values up and down. These y coordinates, the difference between them, the distance between them is 4. Right? Now let's look at our horizontal leg. And horizontal would align with this x-axis. And we're looking for the distance from 3 to 6, coordinate-wise, right? Here's one of the x values, here's the other x value. And so that's a distance of 3, right? And I know that 3 squared plus 4 squared would be 9 plus 16, or 25. And so I know that is square root of 25, or 5. I know that's really blurry. I think it's because I don't have a lot of good light right now. But, sorry about that, guys. All right, so let's take that kind of process that we were just going through and try to apply it here. And before we do, I want you to think about, well, how is what we just did a lot like maybe finding the slope of a line? If we were trying to find the slope of this line, right? So just think about that for just a minute, okay? I'm going to come over here, though, and say, kind of focus on what process we're going to take here, right? I want to know how long this is, right? And I need to know the x value of the first point and the second point to do it, right? So the first point has an x value of 1, and the second point has an x value of 7. And so the distance between them from 1 to 7 is 6, right? And over here, if I want to know the vertical distance here, well, what was the y value up here at the top? What is the y value of this coordinate over here at the bottom? Well, at the bottom for us, this y value is 8. And at the top for us, this y value is 12. And so the difference between going from 8 down here to 12 up here, right, is 4. So if I want to calculate that, 6 squared plus 4 squared equals c squared. 36 plus 16 equals c squared. 52 equals c squared. So c is the square root of 52. So do you see how this is a lot like our rise and our run? this was calculating our rise. What's the difference in our y values? Okay. And this was like calculating the run, the difference in our x values. So that's very, very similar to what we're doing, right? It isn't exactly, but you'll do more of this next year when you get into algebra, and especially actually geometry. So notice I kept saying the difference between these. So if I want to do the difference between my x values here of 7 and 9, to get this distance, I'm really just saying, well, 9 minus 7 is 2. And if I want to figure out the distance between a y value of 1 and a y value of 4, I'm really just finding the difference between 4 and 1, which is 3. And it's that difference that I'm going to use in the theorem. 2 squared plus 3 squared would equal c squared, right? 4 plus 9 would equal c squared. 13 would equal c squared. So this is the square root of 13. Okay. So how this is kind of connecting to that slope idea is we're really saying for a squared plus b squared equaling c squared, right? And this was that horizontal one, and this was that vertical one, right? This is our hypotenuse. This was technically the difference in those x values. And this was technically the vertical, the difference in those y values. And that would give us the hypotenuse if we squared them. Find their difference to get the length, square them, add them to get the sum of the square and the hypotenuse. Now, this is something that you'll learn, again, like I said, in algebra and geometry. But for some of you, I think it was probably, reminding you of slope a lot. So I wanted to show you the connection between those. All right, last thing we want to do is to kind of just jot down these steps that we just took, okay? Let's see if I can get this down a little closer for you. Okay. All right, so first step we took, okay, for the horizontal leg length, we'll say A. We're going to subtract the x values of the given coordinates. Now I'm going to abbreviate that coordinates. Okay. And then we need the other leg, or the vertical leg length, which will be B. Same thing. Let's subtract the y values of the coordinates. And the given coordinates are the ones that we're trying to find the distance between, right? All right. So now that we know those lengths, we're going to find the square root of the sum of the squares. I'll put legs here. So we add the square of the legs, and then we find the square root of it, right? So we squared the legs, added their squares, and found the square root. All right, so I do need you to either take a picture or scan or somehow get me a copy of your notes. So make sure you do that. You try to close out or submit in this lesson, okay?